Alright, so it looks like we have 16 and 17, is that all? Alright. 16 says, in many locations, old abandoned stone quarries have become filled with water once excavating has been completed while standing on a 10-meter high quarry wall. So that's 10 meters is dy. Jimmy tosses a piece of granite into the water below. If he throws the rock horizontally at 3 meters per second, so Vx equals 3 meters per second. How far out from the edge of the cliff will the stone hit the water? Alright, well I need time of flight because dx equals bxt. And this is what they're asking the child to solve for. So I'm going to say that dy equals 1/2 gt squared plus byit. He threw it out horizontally, so that's 0. So 10 meters is equal to half of a positive 9.8 t squared. So basically I'm going to take 10 and divide it by 4.9 and take the square root. So 10 divided by 4.9, and then I want the square root of that. So it was in flight for 1.43 seconds. And if Jimmy, the little delightful soul, threw it at 3 meters per second and it flew for 1.43 seconds, 9 to 4.29 meters is how far out it landed from the base of the cliff, or the quarry wall, or whatever you want to call it. Alright, let's look at 17. 17 says, while skiing, Candace encounters an unexpected icy bump which she leaves horizontally at 12 meters per second. How far out horizontally from her starting point will Candace land if she drops a distance of 7 meters in the fall? Just like number 16, 7 meters. So t is equal to the square root of 2 dy over g. Same thing we've been doing. So that's 14 meters over 9.8 meters per second squared. Square root that little rascal. So 14 divided by 9.8, and square root that lovely number. Wow, that works just like that same problem before it, and I think you get the exact same time. Not quite. 42857. So 1.195 is the time. Seconds, sorry, that was dumb of me. And then dx equals bxt. So I'm going to say Vx is 12 meters per second, and t really is about 1.2 seconds. So that'd be 14.4 meters. Alright, now I'm going to pause and see if there's anything else, and then we'll get this. So I didn't do 14, so let me go back and do 14. I apologize, but it shouldn't take too long. Alright, 14 says, at a meeting of physics teachers in Montana, we were asked to calculate where a flour sack would land if it would drop from a moving plane. The plane would be moving horizontally at 60 meters per second. 60 meters per second. And an altitude of 300 meters, so that's the dy yet again. And how far horizontally? So we're looking at this right here. dx equals question mark. Well, we know dx equals vxt, so we need to find our t. Well, t is really just the square root of 2 dy over g if the vertical velocity was 0 initially. So that's going to be the square root of 600 over 9.8. And you know what, it just dawned on me, Barbara, that these kids may be using 10 for gravity instead of 9.8, because on level they typically use 10. So you might have to change your answers a little bit, but that's what's going on there. So now I'm going to have 600 divided by 9.8, and I want to take the square root of that, and I get 7.83 seconds, so that's going to be 60 meters per second at 7.83 seconds. Ugh, come on, little pin. Don't mess with me. So if I multiply 60 by 7.83, I'm going to get about 469. So it's downfield, or downwind, or down, whatever you want to call it, 469 meters, and it's still 300 meters above the ground. I'm sorry, that's not true. I lied to you. It fell down 300 meters. All right, so I think I'm going to stop with that.